Hi, geometry students. I am bringing you lesson 6.1, which is on page 303 of your geometry book. So I would like for you to grab your book, open 303, get some paper. You may want to take some notes. You will have an index card to add today. So this is an introduction to quadrilaterals, just another shape and another way that we work with shapes. I don't think it's going to be difficult, but I do want you to get some of these definitions and the theorem added to your note cards. So let's begin. If you look at the top of your book, you will see something similar to this. And you will see these if you haven't already started to drive. You better learn these, and you will see these out on the road. And each of these traffic signs is an example of a polygon. And each of these is formed with straight lines. So we're not looking at any circles here. There are some curved pieces, but we see the straight lines. A polygon is a plane figure, so when you remember the planes that we worked with, that is formed by three or more segments called sides. Now, please be familiar with all this vocabulary: polygon, sides, vertex, the diagonal. Just make sure you know what those things are. Each side intersects exactly two other sides at each of its end points, and each end point is a vertex. So let's take a look at, you've got this diagram in your book, but here we have 5 different points. We have 5 sides. Remember, we said there have to be 3 or more segments. Now 3 would be a triangle, but 3 or more segments that meet up at these points, which are called vertex. And we saw that same thing in our triangles. Each of these is called a side. Looking to see if there's anything else I want to tell you here. The way that you would refer to this is you'd have to say all these letters: P, Q, R, S, T. So the quadrilateral P, Q, R, S, T, or T, S, R, Q, P. That would be how you would name it. 2 things to point out: you can have consecutive vertices and non-consecutive vertices. So these 2 are consecutive. These 2 are not. R and T are not consecutive. All this information is in your book, so if you need to jot it down for your notes, feel free. It's on page 303. A segment that joins 2 non-consecutive vertices, so from here to here, is called a diagonal. And let me get that diagram up. So R and S are consecutive, but R and T are non-consecutive. However, the line that forms this is called a diagonal, and you'll see it in the labeling here. And we also have another one, PR. So TR and PR are the diagonals for this. So I want you to take a look before we move on. Example number 1 says to identify polygons. Now I haven't put this up in the PowerPoint, but if you look at example 1 and look at each of those, you have to think through whether they are polygons or not. So A is a polygon. It's got 4 sides. But B has this area curved out. Looks a little bit like the moon. And so it is not a polygon. C is also not a polygon because we lack a connection on C. Finally, D is a polygon. Okay, turn to page 304. And now we have the labeling of some of these polygons. And it's probably a good idea if you try to memorize these by sides. So you've got 3, 4, 5, 6, 7, and 8. And so try to memorize them. Just sometimes I get them mixed up. Probably we'll mix them up often in class, but we can speak to each other better if we know these. So we already pointed out a triangle has 3 sides, a quadrilateral, quad, 4 sides. Pentagon has 5, hexagon has 6, heptagon has 7, and octagon has 8. So this is a good piece to add to your index cards, to your toolbox, because if you have to refer to them, this gives you a nice little chart. Let's go to example number 2. I don't think is necessary really to go over. Take a look at it. Number A is a quadrilateral. It's got 4 sides. B is not a polygon because, again, we have some curvature going on in there. C is going to be a pentagon. It's got 5 sides. And D is not a polygon because some of the sides intersect more than 2 other sides. So when you see those 2 triangles together like that, you are probably not going to have a polygon. Let's move to the top of page 305. Quadrilaterals, the diagonal of a quadrilateral will divide it into 2 triangles, each with angle measures that add up to 180 degrees. That makes sense. We know that. So here, measure 1, measure 2, and measure 3 are all going to add up to 180 degrees in each of our triangles. So the sum of the measures of the interior angles of a quadrilateral is going to be 2 times that, or 360. So when you draw the diagonal across there, here you've got triangle number 1, 180 degrees. Triangle number 2, 180 degrees. Therefore, you have 360 degrees. And that leads us to the quadrilateral interior angles theorem. The sum of the measures of the interior angles of a quadrilateral is 360 degrees. The angles added together, 1, 2, 3, and 4, will come up to 360 degrees. Now imagine if we're trying to solve something about triangles and we've drawn a line through there and we're trying to figure out the measure. Well, we have this to help us. And so always remember the quadrilateral interior angles theorem. That's quite a mouthful. So let's take a look at example number 3, and it says find angle measures of quadrilaterals. Well, we already know they equal 360 degrees. So we begin by taking our angles that we already know, 70 plus 70 plus 80, and we don't know S, and so we know all of those together are going to equal 360. Then we have 220 plus the measure of S equals 360. We subtract 220, subtract 220. Wow, this looks familiar, like algebra or something. And we're left with the measure of S is 140, and that makes sense. It looks like a rather obtuse angle, and so that makes sense. So you should be able to then look at these and figure out the measures. So what I want you to do is take a second, figure out the measures, hit pause, and then I will give you the answers in just a second. Okay, if you're back, I assume that you did those quadrilaterals, and funny, they didn't give me the answers in the checkpoints, so I had to figure them out myself. So I'll give you my answers. If you disagree with those, then let me know when we get to class on Wednesday. I might have prize if if I added incorrectly. So on number 5, I got 90. Number 6, I got 65. And number 7, I got 72. So check those. And if I got one wrong, then feel free to come into class and let me know that. You know that I like to be proven wrong. So feel free to do that. So you will be doing some homework on this, and just an FYI, I am going to go ahead and post videos for Wednesday's lessons. They will probably not be me, but my friend that I have used before. And so if we don't have school or delayed for some reason, the full content will be on the Sycamore page so that you don't miss anything. So let me know if you have any questions, and I will plan to see you on Wednesday.